Hello everyone, welcome back to Let's Do Mathematics. In this video, we are going to solve a beautiful JEE Advanced 2020 problem from the chapter Complex Numbers. It's a very interesting geometry based question involving modulus and transformations. So stay tuned till the end. So we have given problem that let S be the set of all complex numbers Z satisfying modulus of Z square plus Z plus 1 is equal to 1. Then we have to check all the correct statements from these four options. So let's start solving this problem. We have given mod of Z square plus Z plus 1 is equal to 1. We can rewrite this as uh, mod of Z square plus 2 times Z into half plus 1 over 2 whole square plus 1 minus 1 over 2 whole square. What we have done here, we have added 1 over 2 square and subtracted 1 over 2 square so that the given quantity becomes perfect square. So this is Z plus 1 over 2 whole square plus this is 1 minus 1 over 4, that is 3 over 4 is equal to 1. Now we can check here. If you put Z is equal to iota, Z equal to minus iota, 0 and 1, negative of 1, and if we put here plus minus under root 5 over 2 iota minus 1 over 2, then this equation is satisfied. So therefore there are more than 4 complex number that satisfies this equality or equation. So the set S has exactly 4 elements. Option D is incorrect. So option D is incorrect. Option D is incorrect. Now we have to check about all these remaining 3 options. So first of all, we are going to find the bonds of mod of Z plus half. So we can write by triangle inequality, we can write mod of Z square plus Z plus 1 is equal to mod of Z plus half whole square plus 3 over 4 under the modulus, and this is less than or equal to mod of Z plus half whole square plus 3 over 4 under the modulus, and this is equal to 1. Now what we have obtained, 1 is less than or equal to mod of Z plus half whole square plus 3 over 4. Now this can be written as 1 minus 3 over 4 is less than or equal to mod of Z plus half whole square, and this is equal to 1 over 4 less than or equal to mod of Z plus half whole square, and this implies 1 over 2 is less than or equal to mod of Z plus half. So we have for all Z in S. So what we have obtained, mod of Z plus half is greater or equal to 1 over 2 for all Z lies in S. So therefore option A is incorrect and option C is correct. Now we have to check about the option B. So we are going to find the bonds of mod of Z. So let's start to find out the bonds of mod of Z. Now we can rewrite mod of Z square plus Z plus 1 can be rewritten as mod of Z square plus Z negative of 1 under the mod, and we know that mod of Z1 minus mod of Z2 under the modulus is less than or equal to mod of Z1 minus Z2. Therefore taking Z1 as Z square plus Z and Z2 is equal to negative of 1, we can rewrite this as mod of Z square plus Z minus negative of mod of negative of 1, and this is less than or equal to mod of Z square plus Z minus 1, that is mod of Z square plus Z plus 1, and this is equal to 1. So this is equal to 1. Now we can rewrite this as, so this is equal to 1. Now we can rewrite this as mod of Z square plus Z minus 1 is less under the mod less than or equal to 1. Now we know that mod of x is less than or equal to a, where a is greater than 0 implies negative of a is less than or equal to x and x is less than or equal to a. Therefore this inequality can be written as negative of 1 is less than or equal to mod of Z square plus Z minus 1 is less than or equal to 1. Now if we add 1 all the sides in all the sides of the inequality, therefore minus 1 plus 1 is less than or equal to mod of Z square plus Z minus 1 plus 1 is less than or equal to 1 plus 1. So what we have obtained here, 0 is less than or equal to mod of z square plus z, and this is less than or equal to 2. Now we know that modulus is always greater or equal to 1. Therefore, we have obtained here mod of z square plus z is less than or equal to 2. So this is the bond of mod of z square plus z plus z. Now we can find we can rewrite z square plus z is always greater or equal to mod of z square minus mod of z, and therefore this is less than or equal to 2. Now this can be written as mod of z square minus mod of z is less than or equal to 2, and this can be written as mod of z square minus mod of z minus 2 is less than or equal to 0. So by factorizing it, we can write this as mod of z minus 2, and this is mod of z plus 1 is less than or equal to 0. Now we know that mod of z is always greater or equal to 0. Therefore, mod of z plus 1 is always greater or equal to 1. Therefore, mod of z plus 1 can never be less than or equal to 0. Then only we have a choice that mod of z minus 2 is less than or equal to 0. Therefore, this implies that mod of z is less than or equal to 2 for all z lies in the set S. Thus, what we have shown, we have obtained here bonds of mod of z, that is modulus of z is always less than or equal to 2. Therefore, option B is also correct. Therefore, we have obtained that option B and option C are correct choices for the given problem. Thus, we have solved this problem. I hope you have understood all the process of the process of the solutions. And if you found this explanation helpful, don't forget to like, share, and subscribe to Let's Do Mathematics for more such JEE level concept breakdowns. Thanks for watching. I'll see you in the next video. Thank you.